Yeah, hi everyone. This is Shivakant. So today we will be having a LLD session, LLD design session, where we will be designing in-memory distributed queue like Kafka. Yeah, so thanks for joining. Let's make it a great session via collaboration. So let's get started. So here the problem statement could be something like design a in-memory distributed queue like Kafka. So the scope could be or could not be clear, very clear. So it depends on the person who is asking or whatever you recall. Definitely try to ask more clarifying question. And if you have seen this or any of similar design topics where you have these requirements that are clear, then go ahead and explicitly get it clarified where you will get more of the bonus points. And yeah, so there are I think already some websites where these kind of requirements are mentioned. And also, like if you are designing Kafka, most of the things you would be knowing like at high level, like what all components does it have, and at high level how the things works. So yeah, so that's about it. So let's get started. So here like what is the requirement in the requirement gathering? We can just put our thoughts here, like the queue should be in memory and does not require file system. There can be multiple topics in the queue. Then a string message can be published via the producer or publisher, and consumers or subscriber can subscribe to the topic and receive the message. So here, there are different implementation possible. One is like there could be pull based or there could be push based. And of course, there will be multiple producer and consumer. Producer can publish to multiple topics. So this is, I don't know, in Kafka, I have not seen this like this, but typically in design, they ask like, hey, can you push it to multiple topics? Similarly, in the consumer, they say that it can consume from multiple topics. I think maybe the API supports it, but I don't know, I haven't used in this way. So here, but expectation is that we have to push to multiple and pull from multiple. And just for kind of, being able to debug this thing, we will print something like this, print consumer ID this on receiving the message. So the queue system should be multi-threaded. iMessages can be produced or consumed in parallel by different producers or consumers. So this is for simplicity, we are calling it parallel. Actually, it will be more like concurrent, so to say. And like more precisely, I mean, I know there is some confusion that happens. Like some people say that, okay, is it LLD or coding? And also typically in low level design, some people will only ask you the building blocks, like, object model, data model, class model. Anything beyond is not the scope of the formal LLD. But this kind of format is called actually low level coding or machine coding, where you are expected to write a code that that will actually you should be able to run. And if it doesn't run, maybe at the very first level, it can get eliminated. So it has to be running. Next thing is like what all features are you implementing? Are you putting some design patterns, and are you making it concurrent, thread safe, and does it lead to deadlock and those kind of scenarios? So we have to worry about it. So yeah, so this is basically the requirements captured in Word here. So yeah, and I just converted into MVP. I think it's the same thing. Security is not in the scope. So till now, the problem statement is clear. Someone wants to add anything here, or they feel that, okay, this is an overkill, it is not required, they want to remove something from here. I'll just give maybe a couple of seconds. And any question posted on chat, can someone please take the lead and ask it here explicitly, maybe Shashank or someone, because jumping there is very distracting. So
sure.
Yeah, thanks Shashank. So any question in this scope? I mean, I can ask Shashank, like any question in this scope. Do you feel that, okay, this sounds good, let us proceed further, or do you think, okay, I also wanted this here, anything like that?
I think Shreyans have a question, right? How can we have in-memory and distributed as well? You can speak up, Shreyans, so that you can express.
Okay. Okay, good point. So I think this is not a distributed. Very good catch. I understand, definitely. So I'll just put it up here. Let me put it like questions here. So in memory and distributed. Yeah, I know. I think actually it is not distributed. So it is like design in memory queue like Kafka. So actually you got me. So yeah, so this is just like a design in memory queue like Kafka. So actually the distributed, it came from here to here. So it's actually wrong. So not in scope actually.
No worries, Siddharth. Thank you.
Yeah. Yeah. Anything else? I mean, yeah, these are the finer things that a pair of eyes can miss, and yeah, so definitely adds value here. Yeah. Anything else? Okay, cool. So let's jump to the next scope of it. So yeah, so the very first thing is we will put some proposed solution section. So here what like last time also someone asked me, like, how will you, for example, you are designing a board game and things like that. So how will you think of the entities there? So there are actually again two approaches here. One thing is, can we do some sort of technical technical naming we can do, or we can do some sort of domain naming here. So both actually works. For example, let's say someone is using MVC framework, so can they directly say controller or model? So yes, they can say model, and then that's completely fine, right? And then they can do some sort of domain naming, like here in this case the producer and consumer is actually a technical thing, right? So this is a technical thing that we are talking about here. This has nothing to do with, I mean, producer, when we are saying actually from the producer consumer we are thinking, and not from the publisher subscriber. That could be also, so this could be message, could be a domain, and some of these things could be overlapping as well. So here what I mean is the producer consumer that I'm thinking. So that way I'm putting this name, and someone can say that can I make it publisher? So again, so similar to HLD, like the low level design are very open ended, so we don't have a perfect solution, and there could be always incremental improvement that can happen here. So yeah, like if you are building something and you infer from somewhere else, you can always keep adding more value here. And similarly, when you are presenting, you get some feedback, so you can add those things to your design proposal per se. So this basically helps you with some sort of entities, or like classes that we are thinking. Similarly, if someone, so there are again, when we are doing LLD design, there are two approaches. One thing is you are thinking from object oriented perspective, right? So OOP is one approach. Other approach is, so you will do relational modeling here. So both actually works. There is no right wrong, as long as you justify that, hey, I'll start off with a relational model. Is that fine, or am I expected to do object oriented programming? So if the person says, okay, do object oriented level, then you have to think in terms of classes, objects, inheritance, abstraction, encapsulation, all those things. So yeah, and if you are doing relational, which is basically EER, then you will have to think from those perspectives. So these are the approaches. You can pick either of them. So now going back to this thing, so at least some of the things I can think of, like what all things so here I'm not seeing much of inheritance or object oriented principle applied much here, but I'm definitely seeing that there is some principles like composition and things like that is applicable. So a queue can have list of topics that I'm thinking, and this is not data structure queue that we are talking about. This is a business queue that we are talking about. That yeah, so basically the domain, I should say domain, I should not mix things. So this is domain or business. And similarly, there will be message. So this is again, message could be anything. This will totally depend on the domain, that what actually we want to do. And so here for simplicity, we are saying that it will have a consumer string, that's all. So a couple of things just to keep our head on top of it is, we can always put like, okay, I'll make sure that to keep it simple, separation of concern. Like if I'm using an interface or a service, I should not have all the business logic there. Can I delegate it to the next level? And then now if I'm building some logic that could be repeated, let's say that I have a double linked list where I put add to head, add to tail, a small block of code. Can I move it to method so that I can ensure that I can just call those methods, so do not repeat yourself. Code for the maintainers, always think about modular, like typically a method should not have more than 10 lines of code, and if it has, try to comment as much as possible. Make things simple to understand. Think about it like, what will you expect if you are going to a company and you are seeing a new code base? So try to think from that perspective that, hey, this is just the interface, this is classes, then this is where I'm wrapping up the logic that no one needs to understand actually. So things like that, and minimize the coupling and maximize the cohesion, composition over inheritance, and of course the solid, which is single responsibility and blah blah. And we can so as part of LLD or machine coding design, we can also demonstrate some of the things like can we demonstrate some of the design patterns. So now the thing with design pattern is we should not forcefully put it, because sometimes it could be a wrong anti pattern that we are trying, but of course you will get some bonus if you are able to demonstrate one or two or design, or at least verbally tell that, hey, I can use mediator here, but in the limited time I will not be able to do that. So yeah, so this is as part of the solutioning. So other thing is like let's say that we are building some sort of queue topic and blah blah. So what all mechanism can we use? So when we are thinking in terms of multi-threading, then we have something called blocking queue, which can provide out of the box mechanism, out of the box collaboration mechanism. Then we will have some sort of wait notify where we can have, or we can have maybe reentrant lock and a couple of other things. So that's all is on top of like solutioning that we can think of, and then we can start jump to the actual solutioning here. So in the Excel solutioning, what we can do here is that the very first thing is that there are two approaches here. Like one thing is like I go at a granular level, I just explain all these things verbally or in a document fashion, like how the topic will be there, queue, message, and these things could be laid out. Or the other approach could be I put down all the combination of some sort of test cases, or basically if anyone is already acquainted about TDD, test driven development, then we can think about, we will just write the interfaces, and we can definitely design the interfaces, right? So we can design the interfaces and code to the interfaces. So that way you don't have to write any business logic. Still you have all the functional aspects available here. So till now everything is clear. I will take a pause for anyone to think and cross question.
That mediator pattern, can you explain? And secondly, are we supposed to use in interview IqService directly as an interface?
Okay, yeah, sure. So what you can say here is, whenever you are coding any of these things, so you can tell them that some of these things are abstract concepts that are applicable to any of the languages, and some of the things that are already available in my language of choice. So can I use that specific thing out of the box, or do you want me to implement that thing? So do you want me to highlight that specific thing, or do you want me to directly use it? So it will be mostly an open discussion, and most likely if you have a lot of moving pieces, they will say, hey, go ahead and just reuse it, if it is not the very core of it. But if it is just the core thing that they are asking you to implement just the queue itself, and there are no other complexities, then you might have to implement some sort of maybe from array or linked list. But I think typically in advanced languages, it may not be expected. Queue is already kind of proven. So yeah, so if they are asking something like design a logger library, then of course you are not supposed to use the logger, because so something at that level, you can think that if they ask you to design something bigger, then the inside pieces you can just go ahead and use this thing. So makes sense, right?
So one quick question may not be related. What is there a limit on the message size in your implementation?
Sure. Let me capture it. Is there limit on message size.
So typically in these message queues, they have a limit, right? I think some of them like AWS is like 64 KB, some of them are 1 MB.
Yeah. So I definitely understand. These things are there. So the reason for these things are, a network transfer. Like typically when we are doing some sort of post or get. So an MB of packet probably we can send. So that's why they put these limits. So as part of this LLD design, actually we don't have any limits. But we can always verify. So here what I'm seeing is that most likely this will not come up as part of the discussion. We can just say that I will have a message string, that's all, and they will pass. Yeah.
So if I had to ask you, but if the interviewer still asks you, let's say, what's your recommended message limit if you have to implement?
Sure. So so let's say that instead of just bluntly saying I'll just put a string message of any size, then what so what we can do is we can align with any of the systems that we know. Let's say that Kafka supports 1 MB event size, let's say. So what we can do is we can say that I will just align with Kafka and I will allow just a max 1 MB size here. And that must have been proven already, so I don't have to worry a lot about it. I know for most practical purposes this size is an overkill, but I'll just go ahead with the standards so that I don't have to worry about too much deep analysis there. So this could be your answer. Another answer could be that you can say that heuristically I have seen that 1 kilobyte is just enough to store most of the things. So can I keep it 1 kilobyte, or can I just raise the ceiling by 10x and I will have 10 kilobyte as the ceiling of the event size, the message size? Is that fine with you? So basically we can ask a clarifying question. So there is again no right or wrong answer here. We can just say that we don't want more events, or we want events with larger size. So typically by design, events with larger size is not suitable. We are not supposed to send images here or binary here. We are supposed to send events only, which is okay, someone arrived. So yeah.
So one more question is this implementation is in-memory implementation. So you're restricted by the size of the memory. What happens if the memory is full and consumers have not pulled the data? Do you drop new packets, or you drop the old packets and make room for the new packets?
Sure. So since this is an in-memory solution, what if so what if the memory is full? So far in the Neva setup we haven't set any limit. Okay, so so what are the options? One thing is can we set a limit on number of messages the system can take? So that way, so this is the very first thing that let's say that I set it maybe up to 100 million messages I can have in the queue. Okay, so now I have to actually compare this to basically the size and this thing. So there all the calculation will play. Let's say 1 kilobyte. So if I am doing 100 mega, so it will become 100 giga. So this is like too large.
I wasn't asking I wasn't asking for back of envelope calculation. I'm asking what is the behavior of your implementation? Is it going to drop new packets, or is it going to remove the old packet and make room for the new packets?
So we haven't set any limit here. So what will happen is it will become out of memory, as simple as that. It will just become out of memory. That's all.
I mean, that's that won't fly, right? I mean, you'll have to say that you will drop new packets, right? Something like that. You won't accept any more new packets.
Correct. So in the current implementation that I am demonstrating, it will just go out of memory and it will fail fast. I mean, whatever. So now the question would be like, since we haven't set a limit, can we set a limit on the number of queues? So 1 million messages I can have in the queue heuristically. So this will require basically code update. Yeah, but this is interesting. Yeah, code update will be required for this. So as of now, it is not addressed, but I can put that limit. Yeah, why not? So yeah. So any other questions?
Or we can add some sort of TTL to the old data, right, which we can drop and allow the coming ones, new ones to be
Sure. TTL to old
processed.
data, yeah. So TTL actually, I think in Kafka, it will be a very different mechanism the workers will do. And it happens at platform level. So as of now, it's not there. We can design it. There are mechanisms which we can include. Let's say if it is in the scope, we can design it. So exactly it will not match Kafka, but at least we have some custom solution here. We can design it. Anything else?
So I think NG is saying in the chat, TTL is there in the
So
message. Okay, go ahead, yeah.
So this LLD which you're implementing, is it like designed for throughput, or is it designed for low latency?
Okay.
So it wasn't that doesn't matter maybe.
Yeah, sure. So this LLD, yeah, sure. Let me. Is it a low latency or high throughput? So the very first thing is, since it is low in memory, it will definitely be very low latency. Very low latency. It will be. Kafka will nowhere come close to this. A very low latency. It will be. So it could be maybe 10 nanosecond, or it will be really awesome. Okay, definitely not milliseconds or microsecond. It will be really low latency, and so it is on a single node. So we will not get horizontal scalability or throughput. This is just for the purpose of demonstrating this thing. So now throughput will actually depend on how strong the machine is, basically how big your personal computer is. Yeah, so it will depend on this. Again, since this is in memory, this will again be like very fast. I'm just thinking maybe we can get 100K QPS easily in memory, because computers are supposed to be very fast, assuming. So yeah, did I answer the question? Yeah,
That sounds great. Like for example,
so
these in-memory systems, like I think MQ, active MQ, they are quite good at low latency, but when it comes to throughput, Kafka is good. So I think your design would be more closer to active MQ or things like that.
Yeah, maybe like active MQ. So now the thing is, this is 1 hour session or something, so we'll not have any of those fancy things. We'll just have multi-threaded producer consumer, and we'll be done just like that. So yeah, so let me now jump to the solution here without doing going into question. So the very first thing will be we will have let me just open it up here. So we will don't look at other things. So so the very first thing we will have is we already talked about that there will be a demo. So demo will have wherever possible we will try to connect with interface, so that we can design on interface, and implementation we can extend later. And for some of these things we can also say that, hey, the implementation will be pretty trivial. I'm not implementing it. So the very first thing will be IqService. So which is basically, or whatever the name you like, it will have 2 things, like three things actually, which is create a topic, create a producer, and create a consumer. So the goal here is that this is a Kafka kind of platform is there, right? So there for creating a topic, there are different mechanisms. One thing is through command line or through some Kafka monitor, some tool, you can create a topic, or you can just configure it in a way that when you are pushing your code to basically your message to a non-existing topic name, it will automatically create a topic name. So that could be configuration. Generally, most of the small to mid companies, they are doing that setup. Only for large enterprises, they will say that if you want to create topics, go through DevOps. So that is there in Kafka. Here, what we are doing is we are exposing an interface. So now here again, Kafka will have dedicated libraries to get the producer and consumer and attach the underlying topic. Here for the purpose, we are just saying that, okay, give me a producer with this name and maybe a consumer with this name. So slightly it might vary. We can try aligning, but as of now, it may or may not be aligned with any of purely Kafka concepts. So now this is so now if I align with this, so what will happen is let me just go into the implementation of this. So what will happen is the very first thing is I will try to use some sort of singleton here. So this is a simplest singleton that I'm demonstrating. There are different ways of demonstrating singleton, like lazy initialization, enum based, and language specific is also there. This is a simplest eager initialization where I will have a static holder, and whenever I call get instance, it will immediately use this thing. There are much better implementation. This is just to demonstrate that, hey, I'm using a singleton here. So now whenever I want to interact with this queue service, I will just get hold of the underlying queue service instance, and then I will say, hey, can you give me the topic? Can you give me the underlying, give me a producer, create a consumer for this thing. So here, basically we will create underlying objects, like creator, producer, and consumer. And for the topic, we will start using some sort of mediator here. So yeah, so till this, is it clear? Any questions on this?
Sure, just a question, though it's not related with directly with that, it's related with Java. So how actually JVM take care about the race condition here, that you're initializing the class level static variable that for your singleton at line 12?
Yeah. Okay. So far, I know I am not an expert here. So the thing is, whenever this class will get loaded, so any instance of this class gets loaded. Basically, the class itself gets loaded. What it will do is it will see what all are the objects. Basically, static objects are there, and if there are static blocks are there, it will build up those, and then it will create an instance of class. So that instance will hold this entity here, and this will be available to all the objects to refer. So yeah, so yeah.
So my question is around that, is two processes actually loading this class.
Yeah.
So does
the class loader,
because in that case, two processes are trying to load as let's say you have a dual core system, right?
Okay.
And both the processes are running on different core, and they are loading this class.
Okay. So this will be little out of scope, but I'll just try to think.
Okay. I just wanted to know that. I mean, if you don't know top of your mind, then leave it.
Yeah.
I just wanted to understand that how actually JVM take care of that.
Okay. I'm actually not sure, so I'll not go there. So yeah, so at high level, what I can tell is the class loader itself will have sequence of events defined, like I have these dependency. Let's say that I have this scheduler, basically this class, which will depend on some other class, which will depend on the other class. So the class loader, the engine, it will determine the graph, and it will build the last dependency. From the bottom up, it will build everything, and it will structure. And for thread safety, most likely some of the components would be single threaded, so that the class loader does not compete with each other. Of course, if we try 8 core or in modern day 128 core class loading, I think it will get very complicated. I don't know if the Java JVM developers would have done that. So most likely some of these components would be single threaded only, the class loading components, so that we don't end up in concurrency situations like you were stated. So yeah, so let's say this in fact that is a technique we use as well, like we use at least in Java enum and these static, where we know that there will be only one instance that is created. here. So because this is loaded only once, and once it is loaded, it stays there. So kind of we are piggybacking on the JVM, so to say. Yeah, it's not explaining much, but yeah. So yeah, so here you can see like most of all these pieces are connected via interface only. There is no implementation yet. Like this is interface, this is the mediator, and things like that. So now shall I go into smaller pieces first, or shall I go into the main engine here? Any priority? So main engine typically will be here, and smaller pieces will be like, topic, how does the producer, what are the consumers, and things like that.
Could you show that IQ mediator interface? What do you have on that?
Yeah, so so this is pretty straightforward. So this is in this mediator interface, I'm just saying, hey, can you add a topic to your mediator, basically queue engine. This is not data structure queue, this is QQ domain. Okay, that's all. So nothing related to any of the things that we have studied so far. And then we will just do publish to the topic, and then we will read message if present. So this is one of the paradigm we are doing a pull based, and we are also maintaining offset here just to align with Kafka as much as possible. Again, purely emulating Kafka would be very hard, and there are a lot of definitely moving pieces that will come to play, and someone will say, hey, what about this feature has come up in Kafka 3.0, is it supported? So it will not be supported. So yeah, so now if you think from the object oriented or LLD perspective, these are the bare bone or the basic things that we want from this mediator. So why we are calling mediator is actually from two places. Someone will add, someone will remove. So we have both the producer and the consumer is there. So they want to be completely disconnected, right? Now, if you want to disconnect the producer, consumer, or the main main demo thread, so how do you do? So typically we think in terms of ATM model, where we will have some mediator, maybe a bank will be a mediator, or ATM itself will be a mediator. You put the card will the card will talk to ATM, it will talk to bank will talk to the ATM, it will talk to your card. So so there actually this design pattern comes in handy, where we don't want to create unnecessary mesh of dependencies. So we give a lot of things to the central component. Just the only caveat with this thing is the central component could quickly become a monolith kind of thing, like heavily that single responsibility principle, it can easily deviate from there. So we have to make sure that maybe 5-7 more, not more than 10 items are there in the mediator. Probably create a separate mediator, and then we have things in more control. So here it is just queue mediator. So this is just fine. So sounds good, right? Any other questions?
Do you think that, we should split this interface as one for the read message, if present, is only applicable to the consumer, and publish to topic is only applicable to the publisher, and add topic is for admin or whatever you call it? So should we split these methods based on their functionality?
Sure. I get it. So regarding interface split and join, what is the right leveling here? Okay, so so there are two things that play a role. One thing is can we have interfaces for each and every functions that we are running, and we will just expose something to some people, and we will not expose something to the other people. For example, it's totally justified here that this could be admin activities. I totally agree. So if this is an admin activity, why do we want to expose it to the common folk? Maybe this is customer activity or client activity here. So yes, so we can actually split it. So just in that benefit of time, I couldn't do, but I think it is possible to do that, and we can separate it out. So this could be can be separated into different interface. So I'm not changing the code right now, because things will start breaking quickly. So, and these are for client activities.
I mean, in the client, that one is the publisher side and another is the consumer
Yeah.
side.
Yeah, so we can also think like, can we break this thing again? So at one level, we have to think like, are we breaking too much? And we have so many interfaces to handle that there are more abstraction than the implementation. So there are scenarios where it might end up there are so many abstract thing and so less of implementation. So what it ends up is there is almost like nothing meaningful here. There is too much noise is there. Like let's say here I have 10 classes and 500. I mean, I'm just going extreme just to explain. 10 classes and 100 interfaces. So many a time people will have to imagine, okay, we have so many interfaces. What do I do about it? What exactly this does? What exactly that does? So it could be an overkill. So we will actually require the right balance of interface a split or join, and similarly we will require the right balance of the correct balance of abstractions versus implementation. So if it is, there are too many implementation, actually there are some anecdotes written in some book. If there are too many implementation, then it will be too complex to debug. It will be like, everywhere there is just business logic. No one cares about what is a contract. Like for example, it has 10 methods, 20 methods, all of them are public. So it becomes really hard to debug. So it becomes too complex, and it becomes almost like almost useless. So we will have too many abstraction, but there is no concrete implementation. You just want someone else to do it, so you are not adding value there. So it will lead to almost like being useless. So it is uselessness versus too much complex. So does it make sense?
That is fine. I'm kind of not agree here. I mean,
Okay.
if we are saying that this is an interface, and which means that is a contract, and we already implemented that, and
Okay.
let's say if we based on your statement, if we avoid to make too many interface and have some method which are not implemented, so that's we actually breaching the contract here. So and to your second statement, second concern, too much implementation. You can have a same implementation, but implement all these interface and provide a method to return that interface, whatever is required here. Let's say you are creating the consumer, so return the consumer interface only. Though
So
implementation is common for a producer and consumer.
yeah, so here what I'm saying is, let's say there is a code which does not have any interface or abstraction. So basically only implementation is there. So it will become too complex. So I think we are not even debating on this. The only thing we are debating here is do we need too many abstractions here? So too many abstraction could also complicate things. Let me kind of give an example. Let's say that I have a let's say I have a vehicle interface. I'm just a little digressing here, whatever is the spelling.
Yeah.
So now
I mean, my point here is that if we are saying that, okay, here's the interface, so whatever contract we have with that interface, it should be fulfilled. That's the only concern. That's it.
Yeah. So what is here is like a vehicle can drive, a vehicle can brake, a vehicle can fill fuel, and a vehicle can open door and maybe close door. So what happens here is, if we start having all these as a interfaces, basically openable, fillable, breakable, drivable, we can do all those. Now what will happen is that when I create a car, I will have to say car is drivable, breakable, fillable, openable, closable, repairable, and whatnot, maybe 10 other things. So at one point these should be clubbed together, right? So because they together make sense, like drive and brake together make sense. I will not have typically have, I mean, at that level of detail, like just drive and forget about braking, right? So so all these things can we better have it in a single interface? I think that could be the balance that I'm talking about here.
Oh,
right?
okay, got it.
Yeah, got it, right? Because these are like very correlated things. Like for example, another example is like if I have a queue, like shall I put all the contracts like pollable, offerable, deletable. We can have all those, but it will quickly get too many. So this is basically, it will become so many things that it will become useless. That is the thing. So anyways, now let me go into maybe in next 2-3 minutes, I will go into other interfaces and implementation, and then I will just go into the core of this, and we will just try to close it here. So I'll start off with the basic things so that we have more grip on it. So the very first thing is that we will have some sort of message that we will have. So what is a message? So message, if you see here, I'm passing some sort of strings here, and this guy does not have any context of basically here I'm passing message. So I'm just passing messages a string, but internally whenever we are putting in the queue, do we want to actually put it directly as a native string? I think it will not be extendable. So why not create a message wrapper here? So the message wrapper will have a message string, and we can definitely we can set some limit on this. On this, especially for production environment. Let's say that I put it 100 KB max size, I will allow. So as we extend the thing, and so the next thing will be like there will be a topic. So what is a topic that we are thinking here is topic will have, what is the implementation of topic? Okay, so this topic will be there, and yeah, it is coming here. Okay, fine. So I have this topic. So in the topic, what I can do is I can enqueue a message, or I can just read a message if it is present. So this is something we are trying to align with the Kafka topic per se. There is no such true thing as topic per se. It is just that we are trying to align with Kafka language. So this is just Kafka language that we are talking around here. Got it, right? So Kafka domain. So now, so what we want to do in a topic is we just want to put a message, enqueue a message, or we will just say that, hey, I'm giving you this offset. Can you give me a message if it exists? If it doesn't exist, it's totally fine. So yeah, so here, so this is one side simple implementation. Then some simple implementation that we are talking about is we will have a producer interface. So this is what we are talking about, the publish and subscribe. So we have those things here as well. So when we are talking about the producer only needs to think about the publish to topic. So I'll just give a message name, and then I will give a topic name, assuming that topic exists. So what it will do is it will, if we go to the implementation, it will just kind of maybe it will have a name just for sake of it. So here what we will do is we will use this mediator. So this is basically, this mediator will coordinate between the producer and consumer, like a broker, like when we try to get a home, right? So there are buyers and seller, and there is a broker sitting in between. So something of that sort. This queue mediator will sit in between it, so that not you don't have to create M into N combination. Everyone goes to a single mediator, and from the mediator it again fan out. So basically something like fan in. I don't know if there is such a concept, but multiple people will merge to a single point, and then they will come out from there. So this, since we created a singleton, we can just get a handle of it quickly. We can also get a handle at runtime, and I'll just say, hey, you are a mediator. Why don't you wrap my string message to a message object, because now I'm at a producer level, and push it to topic. So this is what the mediator will do as a abstraction sort of this. We don't have to immediately worry about it, like how basically, as encapsulation is the right word, that the queue mediator as an abstract entity, what does it do in an encapsulated format? So it does the publish to topic. So similarly, we have a consumer. So consumer, I can just say that subscribe to topic. So here the thing is, like we are just saying subscribe. There is no active pull from the the demo level. So that is what will happen at if we go to the implementation here. So we will have some sort of a pull or polar mechanism here. So far, is it clear? I think I'll take 2 more 5-minute break, and I'll try to wrap up this one. So far, this is clear. Is it getting overwhelming? Actually, there is good amount of code here. Just if someone feels that why this has so many classes. Yeah, so I'll just go ahead. So here there will be a consumer. So consumer, again, this will talk to a mediator, like the producer and consumer, or the publisher and subscriber. They won't talk to each other. They will just say that, okay, I'll put to some I'll connect with the mediator, and then I will poll from that mediator. So what it will do is the logic is very simple. So logic is like I'll create a separate thread of consumer, and maybe there is, of course, there could be scope of improvement. No. So all these consumers, I'm creating a separate thread here. So this thread, what will happen? I'm just doing true here. So it will see what all topics I have subscribed to. So let's say I have subscribed to topic 1 and 2. It will iterate over both, and then it will read the messages, and it will update the offset of those messages here. So and yeah, so where are we maintaining the offset? Yeah, so it will just consume that message, and it will update the offset of that, and it will put back to a map. So we are maintaining a here topic to offset map. So where for each topic, for each consumer, will have a certain offset. So for example, I'm reading a newspaper or a stream of information, and one of my friend is also reading. So if we are reading from the same physical paper, there will be just a single offset, right? Second page, are we on the third page, page 3 basically. So but if we are reading online, my friend and I could be completely at a different page. So here that is that kind of thing that we want to maintain, like that for each consumer I want to have different offset, and that too for different topics. Like suppose I'm reading sports. So let's say sports is my topic. I'm on the first page, but maybe in movies I'm on the 5th page, something of that sort. So this will just read all the contents, and it will take out. I think some nuances of concurrency are not very strongly adhered here. Yeah, so I think it is not very it's not thread safe. I think so, it's not thread safe. So maybe we will try to cover that. We will see. So this is the consumer, this is the producer, and finally this is the mediator. So what is happening in the mediator is that now whenever we are saying that, hey, publish to this topic, what it will do is it has access to each of the topic. It has a string name topic and the actual topic object it is holding. So it will get that thing, and then it will inside that topic object. So that topic is actually internally a queue only. So it could get overloaded for some people. So this is a queue. So in each, it will push all the messages to the queue, and it will just stay there forever. And we are not deleting per se in this paradigm, because we are trying to build some sort of Kafka kind of thing. So we'll just put all the messages, and we will have an offset for there. And if someone wants to read, what they will do is they will say, hey, give me this messages. So what it will do is it will read it will try to read the message. So now this is largely the scheme of things. So now what I can do is I can maybe show some of these sequence diagrams, so that at least life is simple here. So let me kind of run it here. So yeah, so whenever my actor is calling a queue demo, it is just calling the main, and it is getting the queue demo here. So now can I do some sort of sequence diagramming here? So yeah, so let me just do run demo.
Shiva, can you please increase the font size a bit?
Yeah,
because
sure.
I'm not really getting those sequence diagram very clearly.
Yeah, this is very small actually.
It's visible on the desktop. I mean, I think on the phone it's difficult.
No, on laptop also it's a bit small, right?
Slightly. I don't want too much.
Okay, let me
Yeah,
see if
that
I'm
should
able
be.
to. Let me see if
Continue.
I'm
Let's.
able to. No, no. Let me see if I'm able to update that. If there is a mechanism, I'll yeah, it is
So
possible.
this
So let me.
this IntelliJ provides you to draw this sequence diagram, right?
Yeah.
Uh,
Thank you. That's fine.
Paid version actually allows, not the free version. I think free version has some these object modeling. It does not have.
Oh, that's awesome. I mean, it looks
Mm.
like a sequence diagram. Yeah.
So here, okay, just let me see if I can increase the base font as well. So, okay, so can I make it 20? I'm just thinking where this font is coming. So just give me a sec. I'm just trying to see if I can increase. Did it increase? I think it did increase, right?
Yeah,
So
it
this is
increased to some extent. Yeah, it's fine. Yeah. Go ahead.
yeah, cool, cool. Now it would be readable. So now,
What's the difference between the green and the yellow boxes?
so yellow one is the implementation, green is the interface here.
Okay.
Oh, wow. That's nice.
Yeah, so you can actually with the help of this tool or any other tool, you can just show them that, hey, this is how my sequence of events are happening. There is an actor which is running down and this create topic, so it is moving through so many pieces. So now you can at least visualize one step, right? This is becoming like, I don't know, a cake tower of some rich people. So yeah. So yeah, so this is creating a topic which in turn is creating. So from here we are going to the IqService, which is just an interface. It should not have too much logic, and from there it goes to the via the interface, it goes to the implementation or the mediator. But mediator also is a mediator. It should not handle too many business logic. So it will go to the IMPL and it will just return that object. So this is one part. And the very next is like, again, we are creating the topic. So we are getting, 5-6 steps here. So we can pretty easily visualize that thing here. And then when we are saying that, hey, create a producer, so it's pretty simple. We are just returning the producer one instance of the producer. It is directly yellow, basically the implementation. Similarly, all these producers and consumer are directly coming. And finally, subscribe. So how is the subscribe happening? Is it is telling to the interface, hey, subscribe, and the interface is actually coming to the consumer and it is subscribing. And finally all the messages are subscribed. Finally, publish to topic. So how the publish is happening is, I have a connection to the producer, I'll just say or publisher, whatever. So I should actually say consumer. Okay, anyways, it's fine. So I'll just put it to the producer will publish to topic. And from there it actually goes to the producer IMPL, which will do publish to topic, which in turn goes to the queue mediator and then finally publishes to the queue mediator IMPL, which in turn go in queues to the high topic. So this is the, a lot of complicacy here, but this is how actually it will be very, very extendable. And because there is a mediator pattern here, so it will always be little complicated. That's, you are moving from, one world to the other world, so to say. So this is how the message will go here, and it will get available and queue to the topic. So let me explain again. This is the queue demo. From here, I get an handle of iProducer interface. I say, hey, publish this message. This actually goes to the producer implementation. From here, actually, it creates the message for me because I was using a string. And then the very next thing it will do is, because producer does not have business logic, it will just say, hey, mediator, can you help me with the next step? So it will say, hey, let me publish it to the mediator. So from the interface, it will go to the implementation. Implementation will actually get hold of the underlying topic object, which is again an interface. It will say, hey, can you enqueue to your topic, Kafka topic, basically. And it will say, yeah, why not? So it will enqueue here, and then it will just return. So all these things are happening. So this way we will be done with publishing, and the consuming part is not visible here. The consumer will be visible from the consumer itself. So what we can do is we can come to the consumer and let's say that, can I run a sequence diagram here? So yeah, why not? So, this is not done. So I'll have to jump here because this guy will not know that, okay, from here it is jumping. So let me just do this. So yes, now you can see. So what this guy will do is, this is my actor who is running the consumer runner, which is actually my, the thread and all. So here, so what it will do is it will say thread.start and it will schedule this as a runner. And so what it will do is it will trigger the consumer IPL. So it will just go to the queue mediator, and from queue mediator, it will go to the topic. From the topic, it will get the topic IMPL. It will read the messages from there and it will finally come back here. So this is what we are trying to do here, just that we are trying to do in loops. So this guy does not care about loop much. So it just goes and, does this thing. So this is what is implemented here, right? So we can clearly see here. So any other questions here?
Where is this
I hope-
consume method implemented at line 42?
Consumer.consume. Okay. Yeah, sure. So this is just a dummy wrapper. What I want to do, let's say that, so here I'm just saying, hey, I just consume this message. That's all. So yeah, nothing much actually. So just for debugging, I put some other things like which thread actually processed, what was the underlying message, what was the topic name, what was the offset that was set for this. So this is just debugging. So this is basically the business logic of consume that we are doing. It will be actually externalized. It will actually, what you will do is in the real world, you will process that message. So that is what we are putting here. So this could be passed as a lambda of this consumer. Probably can I pass a lambda to the constructor of this consumer? Probably that could be an enhanced version of this, where I don't put an implementation here from the top. The implementation will come here, something of this sort, maybe a runnable or something, and I will just run that thing, so to say. So that could be one improvement I could think of. Anything else?
So I saw somewhere re-entrant lock, right, while enqueuing the message.
Okay. So okay. I think I'm really sorry. So I think I have mentioned that I wanted to do this, but in this code, I think I haven't taken care of multi-threading yet. So
Okay.
it's not there here. So a little bit of extra work will be required. So what simple thing we can do is, whenever we are saying this list has subscribed topics. So here, okay, no, where is the yeah. Here we have iTopic. Yeah. So here, okay. Finally, it is implemented here. I thought I did not code it. So here, yeah. So what I'm doing here is there are two options here. One thing is, that whenever we are using the queue, either we can use, a simple, a simple, maybe a blocking queue of sort, which will be thread safe out of the box. Okay, alternative is, just use, thread safe queue, or we can have a custom implementation here. So custom implementation we are having here is that we will use a basic queue and we will use some sort of locking. So what is locking is basically the critical section where whenever I'm adding something at that point of time, if someone is checking the size of this, so it could return me empty and or one value, and then I immediately insert the value, then it could behave very erratically. So the right way would be that because this is not thread safe, that whenever I'm adding something to not thread safe APIs, I'll first of all put this in lock. So the traditional method for this was it was synchronized on the queue, but it does not have too much control. So we use a more modern maybe some sort of lock. So reentrant is one of the option. Actually here the right example would be use some sort of reader writer lock. I think I can can I change it to reader writer lock? So there are some specialized locks. So that way I will have full control that I'm adding, then only I'm just putting it in this critical section. Otherwise, once I go out, I'm totally free. I can just use that message. I can do whatever I want. So yeah, so we have multi-threading, and it is just available here, and this is just fine. And this is in the scope of that specific topic. So yeah, basically thread synchronization sort of.
So
So yeah.
Sorry, go ahead.
So I have nothing actually. Go ahead.
Yeah, can you go to, I mean, how is this consume happening? Like in the main function at the very beginning, you showed me that there are like 5 consumer which subscribe to topic 1, and then some of them also subscribe to topic 2. So that's on one side. On other hand, you have this consume runner which calls this consume function in the same file. How are they linked? Is the consumer giving you some callback in the main function?
Okay, so main is just the trigger here. So here this is just trigger all actions and move on. So there is no callback here. So as of now, in the current implementation, the consumer will only, yeah, so here is the consumer. Where is the consumer? So the consumer, what it will do is it will take the message. It will basically, using this consumer runner or whatever, it will iterate over all the topics. It will consume the message, and the message consumption is as simple as it will just write this message.
So
that is, yeah.
So who is calling this consume runner? So consume runner is in a tight while loop, right? Infinite while loop. Who is calling that?
Yeah, so this is actually a separate,
thread?
A separate consumer thread.
Okay.
Yeah.
So even though you have 5 consumers in the main program, which is subscribing to topic 1, and then like another 3 consumers which are subscribing to some other topics.
Yeah.
But in this current implementation, they are all being processed by this one for loop, right? The consumer runner loop. Am I right?
Yeah, sure. Yeah, sure. So let me explain what is the slight difference here. So actually, when you see here, little deep dive here. So what you can see is I'm getting so many producer 1, 2, 3, 4. I'm getting so many consumers here. So all these consumers are actually a separate object in itself. You just go here, and you can see that it is creating a separate object, and because they are completely separate object, they will have their own executor. So right now they will have their own separate thread. So
okay.
So the only, yeah, so they are separate. The only thing is there is a single runner. So all the topics, it will iterate one after the other. So this is like single threaded actually, iteration.
Okay.
Iteration over multiple topics is single threaded in this implementation.
So at a high level, each consumer is having its own thread, and within that thread, a separate thread is doing this for loop. Okay. I got your point now.
Yeah.
Okay.
Yeah. So in real world, these will run as a separate microservice or sort in a different machine. Yeah.
Yeah. So who owns this guy, the consumer, which you have created? Let's say we have 5 consumers, and now you have 5 threads, each of them running the consume runner. But within the consume runner, you're reading it from a queue, right? You're reading it from the queue mediator, right?
Yeah.
So who owns the queue which actually contains the source of truth? Is it the producer, the mediator, or the consumer?
Yeah, so none of these actually people own this thing. This is owned by the topic itself, Kafka topic. So the mediator only has access to that Kafka topic. So if you see this flow, so this will go to the consumer IMPL, mediator goes to the topic. Okay. Topic has the message. So topic is having the queue, the messages. Basically Kafka
Can
thing.
you show
and
the topic implementation again, please, just for a second?
Sure. So I'll go to, this is the topic interface, and this is the topic implementation. So this is kind of, we are aligning with
okay.
So it looks like to me that it's a push implementation, not the pull.
Push implementation, not the pull.
Because
okay.
you are pushing the message to consumer. Consumer are not pulling here.
Yeah, I would think the same too, the way it's written here.
Actually, I think that it is pull because I have coded it that way. So here, what is happening is
let's assume this is inside, and let's take your word that where you mentioned that we can pass the lambda here, and let's say this consume is a lambda.
Yeah. Sure.
So then your consumer on your server side where you are maintaining all these topics actually pushing the message.
Okay.
Yeah, I agree. It's
Okay.
push, not pull. Because for pull, the pull has to be in the client code, not in your code.
Yeah, when consumer your client initiate the call to pull the message.
I am okay. I understand the nuances. Partly, I'm so. I think let me just take it as a note, and I'll think around it. So, is this pull or push implementation? The way
my take here will be, I mean, if in your implementation where you are creating the consumer, so instead of that, if your consumer, could you please go back to your main where you are creating the consumer?
Sure. So here, So here, this mediator, I'll go from the top. So here, I say that create consumer.
Yeah. So when you create the consumer, so return some interface and pass this interface to some client, and then that interface will have that method, say like read message kind of thing, and consumer in a separate thread will use that interface to call that method.
Correct. So that way, this consumer will push the message to the clients. I'm getting more precisely. So, and in fact, why should this consumer do this thing? This should be totally moved out. So I think I'll need to make a little code changes here. Now move this out. And then sure. Then I understand that this system, because this system is running and this is pushing the messages to the consumer, hey, can you run it? Hey, can you run it? So but if we consider that the consumer is a separate component, then we can say that the consumer is pulling from the message. So it's kind of a little debatable. So if consumer is owned by someone else, and I just own the consume logic, then it is called a push model. But if consumer code, basically the consumer is part of the backend logic, then it can be called a pull model. So so anyways, so almost like they are sounding similar, but there are caveats.
It's more of a polling. When we do polling, it's more like we are pulling the data. When we poll the topics continuously.
So I kind of agree on this. Yeah, surely. So anything else?
So one thing I didn't understand, Shivkant, I get it that the offset topic is like an index, which is on which we have to, the consumer reads that data.
Yes.
But once it is read, does it kind of delete that entry or decrease the offset? What does it do there?
Sure. So regarding the offset and in the current design aligning with Kafka, what we are doing is we are retaining all the messages in those topics. So one of the special reason that is more applicable to this scenario is that at least in this setup is that I have a topic, and that topic could have multiple consumers, right? 1, 3, 4. Now, if one person basically goes and deletes that message, what will happen is we will lose that information. So so we don't want that. So what we are doing, and just to fulfill the requirement, is that keep the message and just increase the offset of individual topics. So this is what kind of we are maintaining here, that for the consumer will take care of that thing. So it will maintain the offsets. So this is one of the implementation. It can be always debated that why you are doing this. Can we change this paradigm?
Technically, you're decreasing the offset then, right? I mean, or decreasing or changing the offset.
I'm changing the offset. So if you see the code,
Okay, you're
it is
doing
just
plus,
a, yeah, simple, very simple. I'm just doing, plus. That's all. Just align with the Kafka.
So just out of curiosity, original Kafka also does the same thing. Does it maintain it or kind of removes it?
Yeah. So original Kafka actually maintains the
Zookeeper
information.
maintains it. Yeah, Zookeeper
No.
maintains that.
The topic maintains that.
So topic will maintain the message and Zookeeper will maintain the offset. Yeah.
No, nowadays they have the topic itself as a maintaining the offsets also.
Correct. Yeah.
Removing
Zookeeper
from
as well.
Zookeeper, yeah.
So I have one question. Like, suppose you have 3 consumers, and one consumer we change the offset. So for second consumer, like from where he started, that is where it's kept. Like, where is that logic? There is only one object, right? That one object.
No. Okay.
No,
Every consumer
three
is
different
creating
consumer objects. Each of them have their own offset variable.
Yes. You can see
So-
in the consumer there, right? Multiple consumers.
Yeah. Yeah, so I'll just show again. So when I'm calling this, create consumer, it is actually creating a separate instance of these consumers here, and so all those are running in a separate thread, and they will have their own topic and offset, so to say. Yeah.
Okay. Oh, so it's a one consumer, one top. But in general, does it happen like this way? Like one consumer, one topic?
Yeah, for every partition you'll have
No,
offset,
it's
right?
not. It's not one consumer, one topic.
One consumer, multiple topic.
No.
Yeah, sorry, yeah. Yeah.
One consumer.
Yeah, so some of these things in the real world will slightly vary. For example, like we said, in Kafka, this could be maintained by Zookeeper, and also this could be maintained at consumer group level. So we haven't implemented those things here, and there will be again much more complexity, of course. So this is an emulation that we are trying here. Yeah.
Yeah, in 1 hour interview, they won't expect this much, right? I mean, like everything you do the real world Kafka.
Yeah. This itself is like, I think
You never know the way nowadays interviews are going on.
So, but they will actually at least ask a low-level design, right? They might have need a class diagram or a sequence diagram just to explain how things are flowing. Maybe they will ask that, right? Not the implementation, obviously.
It depends. They give you
kidding.
1.5 hours and they will go for a break and keep on coding. And again, they'll come, you'll have to explain, and then they might give you that if you change this, I mean, if and but will be there on that, whatever implementation you have done.
No, I'm saying from a low-level design interview perspective, normally it's a design that is given to create, right? Entities and flowcharts. I'm not sure if they would be asking to code also over there, would they?
The code, you have to code it and make it runnable also. Like it should be executable code. You have to give a demo. Then only they'll consider it as a fulfillment.
So there are purely speaking, actually, LLD should only have low-level design and not code, but machine coding should have just coding and and this design, this sort of thing. But what happens is, many a times these terms get interchangeably used, and we definitely don't want to miss on that. So then eventually what Sasank is telling may happen, like they will say, hey, I want. Yeah, so they will say LLD coding. Let's say they say LLD coding. I want you to be good in LLD coding. So that actually means machine coding more precisely. And if some company says that I want you to be very good in high level design and low level design, so I will have just one interview or one round where I'll ask high level and a little bit of low level. So in that scenario, probably they won't have an opportunity to go and code. So that will be the balance. Yeah.
Or maybe for senior folks, they might not ask to write the code. For senior folks, they might ask for depends.
They are asking me to do 100 lines of codes.
Sure, this is good, man. Thank you.
Shiva, how many days did it take for you to write this queue thing in Java?
Good question. Actually, it takes days to write this.